I'm Associate Professor Chris Cazzonelli. I'm a plant molecular biologist within the Hawkesbury Institute for the Environment at Western Sydney University. I'm a researcher as well as a lecturer, and I run a large team supervising a lot of PhD students. The CRC for Future Food Systems has been funding us for a few projects. One project, as you can see behind me, is running these capsicums under different light-altering films and different luminescent films to see if we can enhance growth and also promote energy sustainability. They've also funded a project that has come to a completion now, where we looked at trying to improve the efficiency of pollination in tomato. It's cost the industry billions of dollars per year to have to use mechanical ways to pollinate tomato flowers, where they use tapping wands or they use air blowers and other ways. And we thought that we could come up with a more of a non-contact way by using acoustics. And in that we're using sound. We figured we could use sound to go in and perhaps use that to move the flowers and move the reproductive organs to promote effective pollination. So that was funded by CRC Future Food Systems as well as Perfection Fresh, and that's been a great project. So they're just two of the main projects that I've been leading through the CRC Future Food System. The Future Food System project, where we looked at bioacoustics and tomato pollination, we had a really nice team. The team was mostly constructed of PhD students, and though we had Sidra Anwar, who's now graduated and got a job in CSI Road, she sort of led the project, and Happy, who came in a little bit towards the end of the project, he's also played a large part in it. And then we had some PhD students from New England University who participated as well, and we had great help from Perfection Fresh. Their growers were an instrumental part, so we had Troy Top and Naresh Singh, and these growers really helped us to understand tomato pollination and what were the problems. And we brought in Professor Chung Wang from the University of New South Wales. He's a mechanical engineer, and he used various tools and equipment to look at the frequency of like the traditional vibrating wand. What sort of frequency was that applying to the flower when you put it on the truss on the tomato plant? So we were able to measure the frequency, and then we used various other devices to look at the acceleration and the velocity of those flowers. And using that, we were able to then test various speakers, and we came up with a subwoofer speaker as being ideal, where we could get anywhere from 50 hertz up to around about 10,000 hertz. Now, bee buzzes a flower typically around about 50 to 400 hertz, and the bumblebee has a very effective way in causing buzz pollination. So what we thought is, if we can measure the frequencies and acceleration of these of sound and how it affects the flower and find those ideal frequencies, we might be able to simulate what the bee does. We looked at the flower and we found frequencies of 50, 250, 1,000 and 10,000. We saw these peaks in acceleration, and they became our testing points to apply those frequencies to difficult to pollinate tomato cultivars in order to see if we could get effective pollination. And indeed we did. We thought that we could save a lot for the industry by creating a precision pollination automation technology, and that sound could be that way because we would not be moving air. Project's gone really well, and we successfully completed that project within 6 months. We published our research recently in the #1 horticultural research journal, showing how effective acoustics could be to promote pollination. And what we indeed showed was that the sonication could promote seed set and fruit size as effective as conventional techniques such as the vibrating wand. So right now that we've published our research, we're looking for industry partners. We're working with the Future Food Systems. We're working with the IP departments at Western Sydney University and University of New South Wales, keeping our collaboration strong as a team to see if we can find some industry partners who have sonication technology, sonar technology, something that we could put onto the end of a robot. We're talking about small little speakers that would have to produce anywhere from 50 to 10,000 hertz frequency. I'm really positive about food production. The things we're doing in this high-tech glass house here is about a circular economy. It's about what comes in, gets used, and then we recycle it. The food that we're producing here is as tasty and as visually attractive as the foods that you would produce outdoors. The future is looking really wonderful and great as we move forward, and I think the Future Food Systems is a great platform for industry to come in and get involved in some of these projects so that we can plan for a future in 10 years' time where our crop production is highly energy efficient and sustainable.